Okay, in this final lesson for lesson 20 on the graphs of logarithms, we're going to identify, I want to show you how to find the base of the log function if you're given just a point, okay? And so, for example, the graph of function y equals log base a of x. Well, we keep saying log base a letter, but we know this is supposed to be a number. But we can find that number if you just give us one point that the log function passes through, okay? So, oops, I misspelled the word through here. Go ahead and put an H on here. There we go, through. That's much better, okay? All right, so this log function passes through the point 5, 1 on a graph, and so we want to know what is the base of the logarithm, okay? So what we're going to do is this is an x value, the 5 is an x value, and the 1 is a y value. So we're going to put the 1 as a y value in for y, and we're going to put 5 as an x value in for x, and then we're going to solve for a, okay? And so we're going to do 1 is equal to log base a of 5, okay? So you can see we put x equals 5 in for x, and we put y equals 1 in for y. And now what we're going to do is we're going to convert it into a logarithm, or into an exponential function, or an exponential expression. And I know that you're used to seeing the equals on the other side here, but understand we can do it the other way too. We can do a to the first power is equal to 5. Okay, so that's what we have here, is we have a to the first power equals 5. Okay, so this is going to be a to the first power is equal to 5. Well, look at that. First power, a to the first power is just a. So a equals 5. Therefore, a is equal to 5. And this is the graph of log base 5 of x. Log base 5 of x passes through the point 5, 1. Okay, let's try another one. So let's do another one. It says the graph of the function y equals log base a goes through the point 49, 2, and we want to know what a is. What's the base of this logarithm, okay? Well, we see that x is 49 and y is 2, okay? So we're going to put 2 in for y, and we're going to put 49 in for x. So we'll have 2 equals log base a of 49. And so what that means is this is a to the second power, okay, equals 49, okay? So it's going to be a to the second power equals 49, okay? This is a fact. Well, there's a couple things we can do. Let's do it this way. If we take the square root of both sides, the square root cancels out the 2, and all we have left is a, and the square root of 49 is 7. Therefore, a is equal to 7. And so this is y equals log base 7 of x, okay? Let's try another one. All right, so this one says that the graph of the function log base a of x goes through the point 3, negative 1. Now this is weird, 3, negative 1. So that must mean that this part is below the x-axis, because 3 is right here, negative 1 is down here, and therefore, since this is not a reflection at all, it must mean that it's going to come over here and pass through just like this, okay? So let's go ahead and do this algebraically. This is our x value, we're going to put that in here, and then negative 1 is our y value, so we're going to put that in for y, so we're going to go negative 1 is equal to log base a, our x value is 3, okay? So we're going to rewrite this as an exponential statement, and we're going to do a to the negative 1 power is equal to 3, okay? So we got a to the negative 1 power is equal to 3, okay? Now I want to get rid of this negative 1 power. I'm trying to solve for a, and so what I'm going to do is I'm going to put it in parentheses, and I'm going to raise it to the negative 1 power, because negative 1 times negative 1 equals 1, and that's what I want. I want a to the positive 1 power, because that's what a is. A itself is a to the positive 1 power. So if I raise a to the negative 1 to the negative 1 power, I'll have a to the positive 1. Okay? I got to do the same thing over here. I'm going to have to raise 3 to negative 1, because whatever I do to one side, I have to do the same thing to the other side. So a to the negative 1 is just a, and 3 to the negative 1, so that's equal to 3 to the negative 1 power. Well, what is 3 to the negative 1 power? Well, we know that anything to the negative 1 power is now a fraction with that base in the denominator to the positive power. So that's 1 over 3 to the positive 1 power, and we know that 3 to the positive 1 is just 3. So a is equal to 1/3. Okay? So this is 1/3. And therefore, our log equation, or our log function, is y equals log base 1/3 of x. And it is okay to have numbers, positive numbers, that are between 0 and 1 as a base of the logarithm. Let's do just one more example. All right, this last one, we're going to do y equals log base a of x. It passes through the point 16, negative 2. Okay? So we're going to put the 16 in for x here, and we're going to put the negative 2 in for y right here. And so we get negative 2 is equal to log base a of 16. Okay? So that means that a to the negative 2 power is equal to 16. Okay, so a to the negative 2 power is equal to 16. Now I'm going to take a different direction on this. I'm not going to get rid of the whole negative 2. What I'm actually going to do here is I'm going to turn this into square. I'm going to make this a positive 2. So I'm going to raise this to the negative 1 power, and I'm going to raise this to the negative 1 power. Why am I going to do that? Because if this is a squared, so negative 2 times negative 1 is 2. So this will be a squared. I can now cancel that 2 by taking the square root. And maybe taking the square root of this side will help me get at the right answer. So a squared is equal to 16 to the negative 1 power. Well, 16 to the negative 1 power is the same thing as 1 over 16. And so now to solve this a squared, I'm going to take the square root of this side, and I'm going to take the square root of this side. Okay? This is just going to become a. So a is going to be the square root of 1 over 16. But if we take the square root of a fraction, we can actually change it into the square root of the numerator divided by the square root of the denominator. This is a legal move. The square root of 1 over 16 is the same thing as the square root of 1 over the square root of 16. So this is going to be the square root of 1 over the square root of 16. Well, what is the square root of 1? Well, any root of 1 is just 1. And the square root of 16 is 4. And therefore, a is equal to 1/4. Okay? And so our log function here is y equals log base 1/4 of x. Okay? I just want to do one more thing, and then we'll be done. All right, so what we have here is we have a log, the graph of a log function. Okay? It's not a reflection. This is the original. It's not a reflection across the x-axis. It's not a reflection across the y-axis. This is the normal graph. And what we want to know is this the graph of y equals log of x, that's log base 10 of x, or the graph of natural log of x, or log base e of x? So what we're saying, what we're really asking is the base 10 or is it e? And remember that e is approximately equal to 2.718, okay? So here's what we're going to do. Here's the way I want you to understand. If this graph is base 10, then if we were to plug a 10 in here for x, then the answer would be 1, because log base 10 of 10 equals 1. But if we plug an e in for x, the answer will be 1. So log base e of e is equal to 1. We learned that in a previous video. E to the first power is equal to e. 10 to the first power equals 10. Okay? So here's the thing. Here's what I'm trying to say, is that for log base 10 of e, or just log of e, This graph is going to pass through the point 10, 1. But natural log of x is going to pass through the point E1, which is approximately 2.7 or maybe somewhere near 3. So let's go to the graph and let's find where E1 is. That's 2.718. So we're going to go over to 2.718. This is E, right about here, that's E. And then we're going to go up to 1. 1 is right here. Okay, here's 1. So we're going to go up, and here's the point E, comma 1. And it doesn't, the graph is not passing anywhere near that, right? Well, let's go find now 10, 1. So if we go all the way over here, here's 10 right here. And if we were to go up, and here's 1, if we were to come over, look at this, it's right about there. Look, there's the point 10, 1, okay? And so this is the graph of log of x. It's not the graph of natural log of x.